हेलो स्टूडेंट्स, एक क्वेश्चन देखते हैं। देखिए, इस क्वेश्चन में क्या दिया है, एक सर्किट दिया है, ओके, और उसके बाद 4 ऑप्शंस दिए हैं, कौन सा ऑप्शंस करेक्ट है। हमें कुछ ऑप्शंस में देखना है क्या सही है। तो सबसे पहले क्या काम करते हैं, पहले इस सर्किट को सॉल्व कर लेते हैं। अरे एक बार सर्किट अगर सॉल्व हो जाता है तो जो भी ऑप्शन में दिया है सारे ऑप्शंस का हम आंसर दे सकते हैं। तो लेट अस सॉल्व दिस सर्किट नाउ, राइट। So if you'll see here, this is 2 ohm, this is 2 ohm, this is 4, this is 4, 1, 1, this is 2 ohm and this is 4 ohm. Okay, so I can say this 2 ohm and this 2 ohm are symmetrical, right? If you'll see here, this 2 ohm, this 2 ohm are symmetrical, this 4 ohm and this 4 ohm are symmetrical. So I can say from here the current on this 2 ohm and the current on this will be same because these two are symmetrical. Similarly, I can say the current in 4 ohm and current on and the current in this 4 ohm will also be same because both are symmetrical. So if the current is same and the resistance is same, the potential difference across this and potential difference across this will also be same. And same can be said here also, right? Potential difference across this and potential difference across this would be same because the current is same and resistance is same. Okay, so let us take now, so let us call this one as 0 volt and this I am calling as 12 volt. So this is 0, so this will also be 0. Let us take potential at this point is V1. So potential difference across this is V1 now. Okay, so the potential difference across this one will also be V1. So this is your 12 volt, so this must be 12 minus V1. Right, why minus? Because in this direction the current is flowing from higher terminal to lower terminal, and in the direction of current potential always decreases. So from here to here it will be decreased. So 12 minus V1, so that potential difference across this and this remains same. Okay, now I can, right, so I am taking this potential as V, let us suppose. So potential difference across this is V now. So potential difference across this should also be V because both are symmetrical. So in this direction the potential will decrease, right, because the current is flowing in this direction. So here this will become 12 minus V. All right, now see all the points, I know the potential now. There are two unknowns, so all I need to write the two equations. So I will write the junction law at point P and point Q. So let us see, so let us use the junction law at P. So at P I can say, right, what is the current outgoing in this direction, right? Potential difference is V1, right? So this will become V1 upon, or you can say like this, right, 12 minus V1 minus 12 upon 2 plus, right, potential, right, the outgoing current in this one is 12 minus V1 minus 12 minus V divided by 1 plus, now once again the outgoing current in this direction 12 minus V1 minus of V1 divided by 2, right? So total outgoing current must be 0. So we are getting the equation 1 here, right? So let us simplify this. This will get cancelled out. This will become minus V1 upon 2. This will become, right, if we'll see here, this will also get cancelled out. So this is becoming minus V1 upon 2 plus, right, from here this will get cancelled out. So we will get minus minus plus. This will become V minus V1 plus, here you will get 12 minus V, 12 minus 2V1 upon 2, and that is becoming 0. So you can multiply here 2 with 2 here. Okay, so from here the net equation I will get summation of this. So minus V1 plus 2V minus 2V1, okay, and minus 2V1 once again, see, right, minus V1 plus 2V minus 2V1, right, minus 2V1 is equal to minus 12. So I can say here the equation I am getting 2V minus 5V1 is equal to minus 12. This is the equation 1. Similarly I can get the equation 2 also working at Q. So let us work at Q here now. At Q, right? So if I work here at Q, so once again I will use the junction law. So 12 minus right? Potential at this is 12 minus V minus 12 upon 4 plus, right? The junction law at this is 12 minus V minus V upon 4 plus along this is 12 minus V minus 12, right, and plus V1 upon 1, right, and this entire will become 0. So I can say from here, okay, this 12 weight get cancel out. Okay, now I can multiply here, so this will also get cancel out. So the equation will become minus V1, right, and plus 12 minus 2V. Okay, and this I can multiply 4 and 4 up and down. So this will become plus 4V1 minus 4V, and that is equal to 0. So second equation I am getting, see here, this will become, right, minus 6V, and this will become plus 3V1. Okay, 3V1 and minus 6V, and that is equal to minus 12. So this is the equation 2, right? So now if, right, two unknowns are there, V and V1, and two equations I got, I will solve this equation and I will get the answer, right? So let us see what are the equations. Okay, the equations are 2V minus 5V1 is equal to minus 12. Now equation 2 I am getting, right, minus 6V plus 3V1 is equal to minus 12. So I can solve this equation, right? If you'll see, right, the right hand side of both the equations are equal. Okay, so this will be equal to this, and if you'll equate, right, the left hand side of these two, then you will get here 8V is equal to 8V1. See, right, if you look at this to this, the minus 6 will come this side, so 8V, and you can take similarly minus 5V1 that side, so it will become 8V1. So from here I can say V1 is equal to, V is equal to V1. Okay, now if I put this V is equal to V1 in equation 1, so how much you will get? See, right, you will get here V is equal to minus V1, so here I will put minus V1, so this will become minus 3V1, and so minus 3V1 is equal to 12. Okay, so V1 will become 4. So if V1 is becoming 4, so this implies V will also be 4 volt. So now see, right, so V1 is 4. So what is the potential at this point now? See, 12 minus 4 is equal to 8 volt. And similarly, the Q will be also 12 minus V. So 4 volts. So this will also be 8 volt. Okay. So now I know V1 is how much? 4 volt. So this will be at 4 volt. And V is also 4 volt. So this will at 4 volt. Okay. Now I know everything. Okay. Now the circuit is solved, so I can answer all the questions. Right? So let us see option 1, the current through PQ, right? See, across the PQ, the potential difference is 0, so the current will also be 0. So the current through PQ is 0, right? So this is correct. I1 is 3 ampere. So let us see where is I1. I1 is this. Okay. So how much current this I1 will be there, right? So let us see how much current across this will go. The potential difference is how much? This is 12 and this is 8. So potential difference is 4. So 4 upon 2, that is 2 ampere. Right? Because potential difference across this is 4. So 4 upon 2 is 2 ampere. This current will be 2 ampere. And potential difference across this is also 4. Right? So potential difference is 4 and 4 upon 4. So this is becoming 1 ampere. So the total current from here is 2 plus 1, that is 3 ampere. Right? So the I1 is 3 ampere, right? So this is also correct. The potential at S is less than potential at Q. So let us see which is S here. S is this and P is this. So potential at S is less than Q. That is obviously correct because S is 4 volt and P is 8 volts. So, right. So this option is also correct. I2 is 2 ampere. Where is I2? Let us see here. I2 is this one. So since you know in this branch the current is 2 ampere and in this branch there is no current. Okay, so all the 2 ampere will current on this, right, in this branch only. So I2 will also be 2 ampere, right? So this is also correct. So from here I can see all the options are correct. Okay students, I hope you understood this question.